This episode is sponsored by Kendo UI. Kendo UI allows you to build better apps faster. They have a comprehensive library ranging from data grids and charts to buttons and sliders. Plus, you can use their components as plain JavaScript as well as in Angular, React, and Vue. They have a large collection of customizable popular themes like Bootstrap and Material. Go check them out at javascriptjabber.com/KendoUI. Hey everybody, and welcome to another episode of JavaScript Jabber. This week on our panel we have Joe Eames.
Hey everybody.
Aimee Knight.
Hey, from Nashville.
AJ O'Neill.
Yo, coming at you live from sunny Provo with a blue sky, green trees still, even though it's September, and red brick apartment buildings.
Chris Ferdinandi.
Hey, it's the Vanilla JS guy coming in from Boston.
I'm Charles Max Wood from devchat.tv, and this week we have two guests. We have Taras Mankovski. I always stumble over your name. I'm sorry.
It's all good. Hello. I'm in Toronto, and it's actually very sunny right now.
And Charles Lowell.
Hello, everybody. I guess my place, I'm live from the base of Sandia Peak in Corrales, New Mexico.
Awesome. Now, we brought you on today to talk about microstates. Do you want to kind of give us the 10,000-foot view on that?
Unfortunately, I've been corrupted by the implementation details, so my brain is very much focused on the how rather than the what. I'll kind of zoom my mind back up to that 10,000-foot view, and the purpose of microstates, well, there are many purposes, but it really is to be a state management solution for JavaScript that is fun to work with and is painless. And that means a couple of things. One, it means it's going to work no matter which framework you're using. So we use it mostly in React, but Taras was talking about how he was using it in Ember today. And because if you, in the MVC paradigm, which is, in front-end development, we keep trying to escape from MVC, and it keeps on drawing us back. But in the latest iteration, we have this idea of the view being this pure function of the model, but the model is still really, really important. And so if you have this separation between your state and how you actually represent that state, either visually, orally, tactily, the state should be portable across different runtimes and different frameworks. So it should be, it needs to be cross-framework, cross-framework. It should work anywhere that you're working in JavaScript, maybe even if you're working in a vanilla Node application. The next thing is that you shouldn't have to constantly be reinventing the wheel. So there are things that we do with our state that are universal. And so in a talk that I gave about this at the Austin React meetup, one of the example that I kind of used over and over again, and I beat the drum again, was that when you have a number like 5, there are certain things that you can do with that number that kind of define what it is to be a number. And so the example I used was you can increment a number. Right? You can decrement a number. You can add 10 to a number. These are things that are implicit to what it is to be a number. In fact, you could even say that what defines a number really is the things that you can do with it. That's what defines a number. I can't increment a car. I can't decrement a person. And I can't, add 10 to a house. And so if I know what type of data that I have, then I shouldn't have to actually explicitly say how to work with that data. So, and this, whether that is a number, whether it's a Boolean, Booleans can be toggled. That's another operation. And so microstates has kind of at its core, you being able to take the shortcut and say, hey, I'm working with a number, or I'm working with a Boolean, or I'm working with this object that is composed of numbers and Booleans, and then it takes care of writing, or it takes care of managing the operations that you can do on that data. The operations become then implicit with the type of data that you have. And so, for example, you might, if you were using Redux to manage your state, you might have if you're working with a Boolean value, you might write a reducer, say, to toggle that Boolean value. And it'd be a simple reducer where you take the current state and you return the inverse. You'd say like bang previous state is the new state. And microstates takes the view that just the fact that you have Boolean data means you shouldn't have to write that reducer. The reducer comes for you. If you have a number, you shouldn't have to write reducers to increment that number, decrement that number. If you have strings, you shouldn't have to have reducers to add concatenate strings onto them or slice them or do whatever to use. But even if you're not using Redux, you're doing the same thing if you're just using set state. To continue with the React example, if you have some Boolean state, you're going to set the new state to the inverse of the old state. It's the same pattern, but in both cases, you have this boilerplate. And so Microstates very strongly takes the view that you should write your reducer once and associate that with the type of data that you have. And then anytime you have that type, you get to inherit for free those operations. And then finally, kind of the third thing that I wanted to mention is that it really needs to feel like JavaScript. We wanted it to feel like JavaScript. We didn't want it to feel like you were working with some framework for managing state. We wanted it to feel very natural. And so it just uses simple ES6 classes to express your models. It uses simple methods to express the transition of that model from one state to the next. And that's about it. Oh, and it uses computed properties to be able to infer and derive new data based off of those models. And so it really, when you're working with it, it doesn't feel like there's really anything special that you're doing. There's just a few very simple rules, like your methods always need to return a new value rather than you can't mutate the state in place. But it feels very natural. It doesn't feel like a departure. Like if you know JavaScript, you'll be able to work with Microstates very easily. And then finally, you look like you wanted to interrupt. There's some kind of intangibles that are like second and third wave concerns that, like, when you're working with state management, you don't actually realize are a problem until it's too late to really deal with them. And so we can talk about those later. These things like laziness and value stability that you just get for free when you're using Microstates. But I should probably stop there. Does that feel like a good high-level view?
That was a lot.
I know.
There's a lot of pieces. I think that if I was to kind of focus on very specific things, it's a runtime type system that's designed to enable programming with state machines, and it's designed specifically for ergonomics. So ergonomics first and foremost.
See, that's why I wanted you to answer the question, not me.
So what I heard that I really liked was we wanted it to feel like JavaScript, not like blah.
I heard that too, and I'm kind of curious because it seems like the things out there already, I don't know, to me they do feel like JavaScript.
So in contrast, I can share with kind of some of the state management solutions that I've worked with and why I think that they're a little bit different. So I guess we could start with Redux, we could start with Ember Object, we could start with backbone models.
Yeah, and I guess I really can only speak to, I'm talking about Redux. So
okay.
To me that does feel very JavaScript.
I mean, it is. Charles, I was going to say that what's interesting about Microstates is that it in some ways it is a tool that's designed in a particular way, but it's designed to feel natural in a way that doesn't create kind of very contrived boilerplatey APIs.
Okay.
Yeah,
that makes more sense.
Yeah, I mean it's all JavaScript. Right, it's JavaScript all the way down.
Artisanal JavaScript.
In many languages, there's a concept of idiomatic X. I don't think that's as clear in JavaScript because the leadership has changed hands so many times over the years. And what the thought leaders in JavaScript have described as idiomatic JS has often, from one, quote, generation of JS developers to the next, been in stark contrast to that before. But I think what you're saying is that you feel that your pattern is idiomatic. That's
I would say idiomatic, not necessarily idiomatic in a sense. Like, I think for us, like a point of reference for idiomatic would be like idiomatic Ember, for example, because that's one of the things that was kind of the place where we kind of cut our teeth in and realized what kind of state management tools we would like. And so in Ember world, there's a lot of conversations around idiomatic. And, I would imagine the same thing's happening now in Angular. But I personally don't mean idiomatic in that way. What I mean is idiomatic in the sense that it gives you objects that you can work with that do what you want. And they're just simple objects. So
Well, I was going to say, to contrast with like Redux, I mean, it's obviously implemented in JavaScript, but it feels very much like a framework. So, you have your reducers, you have your action creators, and you have your actions. And we just, instead of doing those things, like there are analogs to those things in microstates, but, I think it's ultimately a lot more powerful. But instead of, action names, we use regular method names. We use the name of the method in the class as the thing. As the name of the method. The action would correspond, like the payload of the action would actually correspond to the arguments to the transition function. And then the reducer just corresponds to the method body. And so, all three of those things are packaged and co-located, but they don't feel like there's no extra syntax, there's no extra concepts, there's no architecture there. The only really the API is just a single method called create, which is a strong analog of object.create in vanilla JavaScript. And so I think when I say vanilla JavaScript or feeling, it's not so much idiomatic, but feeling like there's just not much API there. It's just how you would normally express things in JavaScript and then with a paper-thin API.
I definitely see that from reading I was just digging through the docs while you were talking, and it just feels like working with normal JavaScript objects. I like it. And is the idea that this is designed to work with like any library or framework? So it doesn't seem like this is specifically tied to any particular, like framework, library, platform, what have you.
Yeah, the idea, we want it to be something that that developers can invest into and that will last with them for a long time. But it will be one of the things that we spent a lot of time designing the interfaces, the API, and the actual implementation, because we wanted to get we wanted to feel natural, but we also wanted to be a tool that people would want to reach for. So like I personally had this experience. One of the challenges of working on something for a long time is that at a certain point you start to design something, and then it's not that difficult if you've been working on it long enough to lose sight of why you did it in the first place. And so I had this experience just now where I worked with Charles on Microstates for a while. Then I just got back to working on a new Ember project from doing a lot of React. We use Microstates in React in other projects, but this was the first Ember project. And I kind of started off first implementing how things were done in Ember, and then rediscovered for myself what it was about, why we created Microstates. And really it comes down to the fact that Microstates gives you the things that you need when you need them, and you get a lot for doing very little. And the idea is that we wanted to scale very well as your needs change. So you start off having some data you want to represent in a form, and then now you need to change. You need to add validation. You need to add certain conditions, and you need to be able to do that. The amount of work that it should take as you start to add complexity or detail into your application should be very little. And once we've kind of implemented the foundation for doing that, we're now finding that there's very little that we can use it in all frameworks, but there's very little, the framework actually starts to do less, which is really interesting. And I can speak specifically to my experience working with Vue and Microstates, because there's a lot of Vue is a really interesting framework in that it has a little bit from everybody. But yeah,
it's interesting to hear you talking about this though, because I have a lot of friends that they get into React and they love React, and then they start putting Redux into their application. And yeah, they're finding that there's this huge level of adoption and buy-in you have to have in order to make it work. And so, yeah, having something simple that just kind of does the state management in a natural but simple way, I guess is the best way to put it. I think that's really what initially when I saw Microstates got me interested in it.
Yeah, I think one of the core underlying principles is that instead of relying on complex mechanics, it relies on composition. So it can be used in the small, and it can scale up to larger use cases. So it's not like, okay, now it's time to kind of wind up, run, sprint, and try and leap the chasm from no state management solution to Redux. And we might crash against the other canyon wall if everyone on our team can't wrap their head around it and things like that. And so by focusing on being able to define these microstates and build them up incrementally, that's kind of how we're able to, achieve that simplicity, is really by relying on being able to build bigger microstates out of smaller ones. And I think ultimately the litmus test of whether that's going to work, and this has yet to be borne out, is, will we be able to, in the same way that people can distribute React components and Ember components and Vue components. And, you basically, if I have a React application, I can npm install a pretty sweet array of components that that are just sitting there on npm ready for me to use. Would I be able to do the same for a small piece of state? A definition for how that state works. We call them state machines. I think it's a really great design tool for designing how your state's going to work. But, ultimately, in your front-end application, you have some state that is driving it. Would we be able to distribute and share that state? So, say, hey, you're working on a Vue application. I'm going to publish this piece of state for a select box that can then be composed into your application seamlessly. That's kind of the goal that we're going for, and we haven't seen that yet. I don't think, if we would have seen it by now, if such a thing were possible with Redux, but it hasn't happened, and I don't think that we will. And so that's what we're gunning for here.
So I have kind of a stupid question, but where the API for microstates is so close to vanilla JS already, why, and understanding that this thing is really tiny at like 5 kilobytes or whatever, but why would I use it versus just using some of the native functions that are potentially available to me? The one that immediately jumps to mind is the immutability component of it, but are there others?
So it's interesting you say that. In some ways, what we wanted to do was to answer the question of if you were able to represent complex state as kind of relationships of models. So if you think of for example, a table might consist of rows and columns. And so if you had a way of saying, here is a data structure, here's a class that you can instantiate, and it's going to be populated with the right instances of classes, and you were able to then invoke a transition and then get the next, in an immutable way, get the next state, and you have the benefit of you having time travel debugging because of immutability. If you're able to implement that, what would that look like? And if you have a really complex data structure that is you start off with a table, and then that table becomes part of a route, and then that route becomes part of an application, but then that application becomes a subset of another application, and you had a tool that allowed you to deserialize state at that level of complexity, and you have the right objects that you'd be able to invoke transitions on. If you had a tool that did all this, what would that look like? And that's essentially what we've been doing with microstates, is that the really big difference between what you get with regular JavaScript and what you get with microstates when you write very similar looking classes is that with microstates, you get to have very strict control over how your state can actually change. And then that gives you all the benefits of being able to deserialize complex data structures. You could do very sophisticated things pretty easily. Does that answer your question?
Yeah, thanks.
I'd like to add one more thing to this question before we go on to the next one, and that is you mentioned immutability, and I think that's actually a really important part because microstates, they are kind of one of, if viewed in one way, a microstate is really just a function, and these microstates, even though they are immutable, but they don't feel that way. And I think that that's something that is important to capture when we were talking about it feeling very natural, like normal JavaScript, and feeling like natural programming, is when there are reasons why people go with immutability, and that's mutability with an M, is they're very easy to compose, right? If I have two objects, if I've got one object here and I've got another object there, I can just set this other object onto that other object. And that's very easy to do. And it scales. It's very easy to build structures. Big complex graphs of mutable objects is actually a very easy thing to do. And so, there's appeal in that. And we're all very used to that, right? That's what we do essentially when we have our JavaScript constructor. We say, this dot property 1 is this dot property 2 is that. We're, building up these trees and building these graphs. And, it's not to belabor the point, it's just very intuitive. So you introduce immutability, right? And I'm not, I'm definitely an advocate of that. I just think, as programmers, we work with information and it's the most valuable thing. It's like the essence. So why throw it away? Like I said, I don't want to advocate for immutability in this answer, but if that's something that you value, and I think you should, it also introduces a level of complexity to work with, because in order to make an immutable change, you have to destructure your data, make the change at the point that you want, and then you have to restructure it before returning it to your application. If you only have like one level of nesting, that's not so difficult. But if you have 3, 4, 5 levels of nesting, you have to destructure, and you'll actually see this a lot in Redux reducers where they want to get at some piece of data. And so they're doing a destructure and a map, and a destructure and a map, get to the piece of data, change it, and then, build it back up. And so that you have in your actual transition, your state transition, maybe 80% of your code is dealing with navigating to the point where you make the change, and then navigating back up from where you made the change, and only 20% is making the change itself. And so one of the things that's nice about microstates is it means you don't have to compromise. You can have a immutable object, but not have to deal with packing and unpacking it. So it feels, in fact, one of the times we demoed it to somebody, they were like, how is this immutable? Because it feels very much like it's mutable, but it is in fact immutable. So you don't have to make that trade-off. So
I kind of wanted to ask a question too, because the one thing I do like about immutability and using Redux is how easy most of it is to test. So can you kind of explain like the testing story for microstates?
Yeah, it's really straightforward. You essentially have your class, which describes your data structure. And so if you want to test it, there's a few different things you could test. And so one thing that you might want to test is like what happens if you invoke a specific transition. So if you have you might have your application state composed of a modal, a list of few things, and then you want to, for example, change something in one of the items in the list, and then open the modal to get user's confirmation or something. So if you wanted to do something like that, then what you would do is you would instantiate a microstate of using the data that would be inside of your microstate. So you'd have some serialized values. So in Redux world, you would think of this as just like your POJO that is stored inside of the container, inside of the store. And so you take this POJO, you pass it to create, and what you get back is a microstate object. And so now what you can do with that object is you can assert on properties of that object. You can invoke transitions on that object, and then the result of that transition is going to give you the next microstate. So you can then assert that the next microstate that you received does in fact have the change that you applied to the list item, and then the modal is open. So it's very little ceremony.
Yeah. From what you're describing, you did a really good job of explaining it because it sounds pretty straightforward and simple. I'm sure you run into cases where it's not, but for most cases, it seems pretty simple.
Yeah, one thing that I really like about microstates is that it makes the things that are usually hard easy. Because we can speak a lot to the value of immutability, but for people that like immutability and that like React, they've already kind of bought into it. But there's a lot of people that use Vue, that use Ember, that use Angular, and for them, they're like, well, mutability is nice and easy, right? But the challenge is that with mutability, you lose control eventually. And when you lose control of your state transitions, you get so confused. And you don't really have a path of transition. You don't have a way to navigate your way back into clarity. And that's what microstates does, is it tries to bridge this. It gives you the mental models that you're familiar with, yet it gives you the purity and the order and structure that immutability provides. And it gives you a really clear path to do things that you need to do. So for example, if there's a property that you have on your object, but you now need to change how you change that property. For example, a simple example is if you have a form and the form is representing a text, it's allowing user to input a number, and that number, because the way that it comes out from the event, it comes out as a string. So if you have a data structure that contains that number, ideally what you would do is you'd want to convert that number, that string that user typed in, into a number before you store it in your state. Like that kind of thing to do with mutable system is actually surprisingly difficult, because you can bind your event or your two-way bind your property to an object, to a model, but then you don't have a way to like interject yourself when that value is being set. And so this is like a really simple example, but it's something that happens at a very like micro scale, and then it also like has a really big architectural impact at the macro scale as well.
Yeah, because you can, I mean, really, no matter which system you're working on, really, ultimately the only constant is change. And
yes.
And mutability destroys change, right? Because you never can tell where you came from. You can only see where you are. It's impossible to, interject some process between then and now, or now in the future.
So one thing that I kind of want to drive to with this, because we're talking about a lot of the benefits and some of the philosophy and, process behind it. But let's say that I have an app and I realize that I need state management, right? It's not so simple that I can just kind of manage it in memory, or, just throw some basic client-side, storage at it. I need something to manage it because a lot of stuff is touching a lot of stuff. How do I go about putting microstates into my app? Let's say that it's, it's one of them, it's using Angular or React, and, it's like, okay, how do I get my data into microstates? And then what does the API look like to manage it?
So the really cool thing about microstates is that because we've decomposed the APIs to a point where it's very precise. So like I can actually tell you exactly what the integration looks like for any framework. So the overall process is the same. So essentially what you have is you take a type, which is your ES6 class, and you pass that type and some POJO, some value, to the create function. And so what you get is a microstate. Now from here, what you can do is microstates comes with a function called store. And so if you pass a microstate to a store, so store takes two things. It takes a microstate and it takes a function that will be invoked every time a transition is invoked. So what's going to happen is when you pass the microstate to the store and you pass it at this callback function, what you're going to get back is an object. If that object is a microstate that has a very special behavior, which is that on every transition, it returns the next microstate with this middleware type thing, or this callback pre-installed. And so the way that you would do this, for React and for Ember and for Vue, the process is essentially the same. You create a microstate, you pass it to a store, and you pass a callback. When the transition is called on this object, the next microstate, you just set it back onto a property. So in React, you would set it with set state. In Ember, you would do like this .set, and then you would set the property in. So you have this like root object that you use in your in your component tree, but it has like a one point where all the transitions, anywhere you invoke a transition on a microstate, it all goes through this one point for this one callback, where you can then set the next object onto your component.
I mean, it's very similar to the store API. Is actually, that part is very similar to Redux. So Redux has like the create store function, and you can pass it an initial state, and basically a event emitter function, an event listener, so that anytime the state changes on the store. The only difference is because it has microstates has the concept of type, you don't have to actually tell it where you're to find reducers, because it'll just know. And because the data is so normalized, there's other really great things that we can do here. And maybe this is a good time to talk a little bit about the stability benefits and the laziness benefits, because microstates is both of those things. So for example, if you have this way to turn any microstate into an event emitter, that when it transitions, one of the kind of the benefits that you have is this concept of stability. So if I invoke a transition on the microstate, and the result is that the value is unchanged, in other words, I get the same microstate that I got before, it doesn't emit an event. And in fact, it recognizes that internally and is represented by the exact same object. So you have this triple equals stability. And so you can imagine if you have some, stream of events maybe coming over a WebSocket, and I'm firing off a transition, but they're all effectively no-ops, any state that's derived off of those microstates is not going to have to re-render. It's not going to have to do anything because microstates will recognize that this is the same object, and it will it'll take no action. By the same token, like if you were to imagine something like that in using Ember Object or Redux or something like that, you would be dispatching maybe 10,000 actions, let's say in a second, and you'd have to be matching those against all the reducers and running all of them and doing all of that computation. It has stability at that level. And then it also has stability in the sense that if you think of the microstate as a tree, only the parts of the tree that need to change. It has guarantees around this, so that if I change some one object that's deeply nested inside some array, that's deeply nested inside some other object, only the objects tracing up to the root of the tree need to change. All the other objects will maintain the same with triple equals stability. So you don't have to write any key functions if you're in React. Ember has like key functions to kind of recognize that this hasn't changed. In order to achieve this in a Redux store, you have to actually go through a lot of work to match and recognize the data. But because the transitions are so normalized, there's only very certain ways you define very clearly how you can transition your data. Microstates is able to just give you that stability for free. And so that has also the advantage, if you have a huge stream of events that's just changing one node in your tree, that's the only node that's going to be affected. Nothing else is going to need to re-render, and without you having to do any extra work.
This episode is sponsored by Sentry.io. Recently, I came across a great tool for tracking and monitoring problems in my apps. Then I asked them if they wanted to sponsor the show and allow me to share my experience with you. Sentry provides a terrific interface for keeping track of what's going on with my app. It also tracks releases so I can tell if what I deployed makes things better or worse. They give full stack traces and as much information as possible about the situation when the error occurred to help you track down the errors. Plus, one thing I love, you can customize the context provided by Sentry. So, if you're looking for specific information about the request, you can provide it. It automatically scrubs passwords and secure information, and you can customize the scrubbing as well. Finally, it has a user feedback system built in that you can use to get information from your users. Oh, and I also love that they support open source to the point where they actually open source Sentry if you want to self-host it. Use the code devchat at Sentry.io to get 2 months free on Sentry's small plan. That's code devchat at Sentry.io.
Charles, I want to go back. Charles Wood, I want to go back to your question. You're asking about how you'd actually use it in your framework. Did that answer the question? Like what we?
Yeah, for the most part. I mean, I just
maybe so you could talk about the thrust, like the actual Ember integration that you were using, or the actual React. Like there is a library called Microstates/React, and this contains a component that you can do where you pass it a type and you pass it a value, and it will instantiate it. It will register that state on a context, and then you can consume that state. So that's the but it's a very thin shim.
Yeah, and so for Angular, for example, one thing you can do, because of the way that the microstates handles with this store mechanism that it provides, you can essentially turn a microstate into, and we use this internally inside of. So we have a observables binding. So if you're using with Angular, what you could do is you could just take a microstate and do like observable from, and what you're going to get is you get an object you can subscribe to, and when you subscribe, you're going to get a microstate that when you invoke a transition on microstate, it's going to stream the next microstate through the observable stream. Mm-hmm. And so, and it's like a one line. If you think about this, like what's interesting about a lot of these frameworks, I'd also add, if you wanted to, I particularly don't care for the connect pattern that's very prevalent in the Redux world, but that would be using the kind of the mechanism that Taras described of just instantiating a store. You could implement a connect too, right, with some sort of provider component. But it's like because the primitive is so small, you can really the number of APIs you can use to integrate, there's no limit.
So essentially, if I'm following, let me just see if I can summarize some of what we've been talking about here. So if I want to pull this in, I can just npm install it. I have Webpack or whatever, build it into my system, and then I just instantiate a store. And then as I transition states, I basically just pass things through the microstate like a state machine, and it moves it from one state to the next, and I get the next state or the next transition possible back?
Yeah, so it defines so it's kind of like, how if you were just using a kind of a vanilla React component, you would bind, you would say, this dot, maybe toggle is open dot bind this. And so you'd bind all these handler functions to your React component, and then you'd pass those inside your template, right? So all it is the microstate. You can either take it in as a property, consume it from the context, but it's basically this object that has a bunch of functions that are those handlers that you can just call and pass data to them, and they will actually perform the transition, update any re-renders that need to happen will happen. But the actual data that you're going to be using to render also has functions associated with it, which are the transitions. So it really is kind of like you're lifting that state and the transitions that operate on that state out of the component. But it's the same basic idea, right? That you've got that state and the transitions that act upon it bundled as one thing that you can pass around.
Right. So your data and your transitions are two separate things, and then you've just melded those together in a way that makes it feel like it's a mutable state machine, even though it's creating a new object and everything every time. Mm-hmm. So it keeps it clean and it keeps it fast. And then I know what transitions I can push it through next to move it through the state machine.
Yeah, what's really interesting is that these frameworks, every framework is designed to help you in some way, but it tends to be very similar. They're trying to help you in a similar way, which is they're trying to manage effectively applying state changes onto a tree of components. So, and what's interesting is that for frameworks that have mutability, so Ember, Vue, and Angular, they have to rely on some complicated reactivity mechanisms that they all really kind of are proud of, because it's really difficult to observe mutable objects and then effectively update trees of components. And then you have a React, which has this idea of a function that takes props and returns a component tree. And so then you have like Redux, which allows you to have like a single data store that allows you to share state across multiple components. And so what Microstates does is it allows you to do kind of a few things. Like one is it does have that same quality of having your data all in one place that you can then share across multiple components in whatever framework you use. But what's really interesting is that for mutable frameworks, it actually negates the need for all of the complex reactivity tracking. Because you can, instead of having to observe objects, all you need to do is at the highest point, you're going to set a property and just cascade that the immutable reference checks through the components that need to be updated. And so exactly, like I can actually, with microstates, I can tell you precisely what has changed for every transition. We know the path and the value that was applied for that transition. It's an interesting...
In fact, you should... Taras made a hack. He actually integrated microstates with the Redux dev tools. And the experience was actually... It was easier to tell what was going on, I would say, with the microstates integration with Redux dev tools than it is with your typical Redux application. But
because microstate takes a type and turns it into a tree. And so each node in the tree has a path. So by having a path, you know exactly what part of the microstate was affected, and you know which transition was invoked. So you have the name. So you have something like .app.mymodal.content, and then the transition is set. And so you actually have a lot of information that you can get simply from just the path and the transition that you invoked on your microstate. And so there's a lot of things that we can do with this. We are just getting started in many ways, but it's exciting to see where it's going to go from here. And we're still learning a lot about what this will allow us.
Mm-hmm. Yeah, it's really interesting.
I have one more question?
Yeah, go ahead.
I have one more after AJ too.
Okay.
So when I think about state machines, I've disclaimer, I've been half listening, half going through the documentation, trying to grab as much as I can while we're on the show. Just when I think about state machines, I typically think of things like parsing or very discrete operations like a literal machine in the world, like a robot that has a certain number of states that it can step through. And we've been talking mostly about front-end frameworks and state management and things like React. So is this applicable in the more, quote, traditional state machine space, like parsing and mechanical control? Or is it really geared exclusively towards view layer type applications?
Absolutely. It can be used in more traditional programming. Any place you would use a state machine, you can use microstates. And in fact, we have an acceptance testing framework called Big Test, which is, well, it does have a view component, but it internally is keeping track of browsers and keeping track of which test cases are running and how they're doing. And all that can be effectively represented as a state machine. And so we're actually working to integrate microstates to represent the state machines inside that. And I think that, separating your state from your actual actions and kind of side effects and representing, always representing the effects of those side effects in terms of state and keeping those separate is always a good thing. And so absolutely it can be used in other contexts.
And when I think about this, just want to add a little bit to it. I really do think about microstates like machines. And this is the difference, I think, from like other paradigms. Like I think over time, I've actually started to think about like when you create a microstate from a type, you're creating from a certain kind of a template of a kind of an object. You're creating an object that you can actually work with. It's like, a method is its arm. You can pull on that, invoke that method and you pass data to it. And then that is going to somehow participate appropriately in the microstate. And I think that's one of the things that is most exciting for me about microstates is that it's enabling the creation of this kind of an object that you can interact with. And if you want to use it to represent a robot, I think it's really well designed for that. Yeah, and I think it could be pretty, if somebody wants to play around with that, I think they'll probably get quite a lot out of it. If they want to apply microstates to something like IoT or something, I think it'd be a really good environment, especially in Node.js.
Thank you.
Joe, I know you have a lot of experience with Angular. I'd love to get microstates used in Angular because I think there's a lot of things that microstates has the same benefits in Angular, I think, as it does in any framework that uses mutability. But also, I think with the stuff that the Angular community is doing with TypeScript, I think it seems like it would be a pretty good fit.
Yeah, I totally agree. Me, myself, I feel like I've got a lot less experience with like RxJS, the Redux flavor and Angular. So a lot of what we're talking about, I'm trying to adapt it to. I'm more of a traditionalist, like your traditional state, that hopefully by the time I hit 100,000 lines of code, I don't want to pull my hair out over. But there's definitely a few people I'd actually like to talk to and introduce you guys to about this particular topic. But going back to my question, from my perspective of somebody who's maybe not necessarily got as extensive experience in a Flux framework, right? And I look at the microstates pattern, where would somebody like that start? Let's say I've got a regular application or I'm about to start an application, one or the other, and I haven't been doing any Flux pattern. And all of a sudden I listen to this podcast and I think, man, this seems pretty kind of cool. Maybe this is an interesting solution for me. Where would I get started with trying to just the official docs that you guys have put together, or is there other materials that are out there? And is it even, again, the right solution for somebody in that state?
So I can tell you one thing that I like to do, and this is kind of where microstates came from, is, before even thinking about how you're going to implement it, like draw out the state machine that you actually want to represent in your view and say, these are the states that this component or this application or this area can be in, and these are the transitions. This is the transition, and this is the data that's required to get from one state to the other. Mm-hmm. And there is a very straightforward, almost a rote process by which you can convert that diagram into a microstate. And now once you kind of go through that process a bunch of times, you can skip the diagram part. Sometimes, although I actually find it's good to write the diagram out anyhow. But essentially the state corresponds to the type, the arrow corresponds to the method, and the data required in the thing is the arguments to the method. And you can return new states from state transitions.
Right. It reminds me of back in the day doing UML diagrams for state transitions. I don't know if that's anything you have any experience with.
I actually, my very first job, we were using rational rows.
Awesome.
And I don't know, I might say that I bear the scars of rational rows.
If you're not over a certain age, this is going to be a completely obscure conversation, right?
Yeah.
I've never heard of it. Is it like XML?
Yeah. So.
But, I actually went through some interesting processes back then where I was doing kind of the same thing. I was like thinking through the state transitions, and I found that really helped out my development at the time. And of course, things moved on and we stopped doing that sort of stuff. So that's actually pretty interesting. You would talk about that, like think through the state transitions. What about, okay, so that's great.
And I would say do that even if you're not using microstates, quite honestly.
Right. Absolutely. Like that exercise is probably very valuable. So what about like I'm in the middle, I've got it, it's already going and I'm going to make some adjustments to it. Again, do you stop, think through the state transitions and say, whether or not you're even doing microstates, is that an exercise that's valuable to people? Stop, think through those state transitions and decide how you want it to go.
Yeah, one of the challenges I think it's a Trojan horse in many ways to people. If you start thinking about your application as a state machine, your like microstates is going to be the natural tool for you as a solution. But I think what's interesting when you start thinking about the first step of starting to think about your application as a state machine is that you start to realize how implicit and unclear your state transitions are. It can be difficult to tell why change is happening, and even the mutable code, even though it's so easy, but the way that you express the logic ends up looking. It feels like it drives towards confusion, and one thing that you get when you start thinking about state machines and expressing your application as a state machine, you want to have a clear way of expressing that state change, and you'll find it with transitions because they're very explicit and they're very consistent. So you can actually not only can you change your state machine, you can replace specific nodes of a microstate with another type of node. So it allows you to build if you have a form where a user is changing the form over time, like the actual shape of the form, different fields are being loaded and they're being loaded from the server. Like when you have those kind of scenarios, you actually will find a lot of comfort in the tooling of building these state machines because microstates is designed to enable these different kinds of scenarios. And then for that reason, I think really if you start thinking about I think we've been discouraged by our tooling from thinking about our application state machines. When we start doing that, the natural solution then having a tool that is designed for that. And I think that's where microstate becomes the solution. But there's definitely one thing I heard, I've presented this to people who are very experienced React developers and using Redux. And they're like, oh, I've written a bunch of React Pro applications, but I feel like I'm starting to get to a point now where I'm experienced enough where I want to plan more, and I think that's what there's a certain point where you've written enough of these applications where you actually want to be able to think abstractly, but in a way that is very tangible. And I think that's what visualizing it, and then converting that into code and seeing how the microstate that you drew matches the microstate that you wrote, and then using it. And there's a very interesting feeling that emerges from doing that, going through that process.
Right, I follow you. I feel like it's pretty interesting. Do you guys have much in the documentation about that process of stopping and thinking through your state transitions, and then encoding that into microstates? Is there much guidance in walking people by the hand through that process so they can get used to what that's like?
I gave a talk back in 2016 when this project was essentially completely and totally embedded inside the Ember community. But I outlined that process. I don't know if you remember that, Taras.
Yeah. Well, we need to do. The next step for us is making all of this information accessible. We've been learning about how to talk about microstates because microstates is really deep. There's a lot of we can talk about what we learned from Haskell. We can talk about immutability. We can, there's a lot of elements to it. So we've been kind of shedding certain topics. And I think what we need to do next is actually focus on, this is how you would use microstates in your project and getting people actually using it, because that's at the end of the day, that's what we do. That's what our industry is. And I think that's what we need to do next, is write up those guides to help people use these patterns and actually benefit from them in their applications.
So what's coming next for microstates?
So I can tell you from a low-level perspective, right now we're working on some pretty exciting performance profiling. Like, I think that microstates is actually, because of the benefits of laziness and stability, is actually going to be one of the fastest, if not the fastest, state management solution out there. So, for example, you're going to pay very little. Again, imagine that stream of 10,000 events coming every second. And you want to run them and experience the consequences of those state changes, but you only want to render 60 times a second. Microstates is going to allow you to not experience any cost for just throwing those events. So you'll be able to hook up microstates to a fire hose, essentially, which I think is exciting. Other things on the radar is to just start to build up a body of shareable state for very common patterns. Things like
authentication is my first. Yeah.
That's your first one. Authentication workflows, asynchronous workflows, things like file upload and AJAX requests, and so on and so forth. I think the next thing after that, which is kind of going to be the next big body of work, is settling on a pattern for modeling side effects inside microstates. So microstates very much is state. It's absolutely immutable. You cannot you cannot have side effects inside of a microstate. I mean, I guess you could, but Taras would come and yell at you, or I would yell at you. But obviously, our programs need side effects. You need something to drive the state forward, and so some conventional mechanism to drive that state forward. Because right now, it's up to you. Kind of like in the early days of Redux, before Saga and Redux Observable, the community hadn't really settled on any pattern for rolling that state on through the future. So I'd say those are kind of the next big milestones. I'm sure I don't know if you want to add to that list. Oh, and also getting integration for more frameworks than just React and Ember and Vue.
Yeah, and getting a documentation. Like we have really good README, but we need to put up traditional docs site, what like every framework has. So that's also on the roadmap. Cool.
Anything else that we want to cover?
I think if anyone's interested in trying it out, we're more than happy to help people who are interested in microstates. So if you have a use case, we're starting to have we're starting to get some traction. Like people are investing into microstates quite substantially, so that's really exciting. But we want to be helpful to people. So if you're interested in using microstates, we're more than happy to talk and help and make it work for people.
Awesome. All right. Well, let's do some picks. Is your job search stuck? Maybe you're not getting any interviews with employers, or maybe you are, but no job offers, or you may be new and not even know where to start. This is Charles Max Wood, and I'm releasing a new course and ebook on how to find a job as a software developer. The course walks you through the process of finding the types of companies you want to work for, getting their attention, and putting your best foot forward as the candidate they want. I've coached dozens of developers in looking for jobs and have been able to help several people find jobs within 2 weeks to 2 months. So whether you're new to development, can't find a great job that fits what you want, or are looking for remote work from an area without a strong tech community, I can help. Go to getacoderjob.com and sign up today. Aimee, do you have some picks for us?
I do. I have one that is really fitting. I hope that it's okay to pick for this episode. Hopefully it's not like competition in some sense, but it was really, really good. It was actually on the Shop Talk show a couple weeks ago. And it was just an episode on working with state machines. And I believe the people who are on that episode actually have a course on this. So I learned a lot by listening to that episode. And if you thought that this episode was good, you might also want to check out that one. So I'll put a link to that in the show notes. And then I apologize. I forgot to drop in my link last week to the show notes. So I don't know if it's too late to make them in for last week, but I will pick them again and include them again this week because they were that good. Again, my one pick from last week was a PDF that Stripe put out about technical debt, and kind of it summarized a lot of things. So there's a lot of statistics on kind of how much time a typical developer spends on technical debt a week. And then the other one was the book Professional JavaScript for Web Developers, because it's an older book, but I thought it was really good back in the day when I read it. And those are my 3 picks.
Awesome. Joe, what are your picks?
Oh boy, have I got some picks for you. Woo, doggy.
28 of them to be exact.
All right, so let's see. I'm going to start off with a blog post that I read that I just absolutely adored. Not because I necessarily 100% all the time agreed with what was said, but because it was a really good topic to talk about. And the name of the blog post was the Developer Experience Bait and Switch. And the crux of it is the idea that we are killing ourselves by doing too much JavaScript. And by too much, I mean quantity-wise. And as the web grows, the quantities of JavaScript that we're putting down are unsustainable. So it's a really interesting talk, and the person lays out some really great arguments about the whole topic. And I think it's, again, a great idea to read about and at least discuss and be aware of, because he actually points out this sort of like blind idea that, hey, as long as the tooling that we're getting with all the frameworks that we're doing make our job as developers easier, then everything is better for our users. But that's not necessarily true. Along with I'm not sure if I picked this on the last show, but the blog post Goodbye Redux is another great blog to read and then have a discussion and think about whether or not you agree with everything that's said or not, which that one also was slightly applicable to today's episode. So that's my pick, is Developer Experience Bait and Switch. I'll put a link to the show notes. I don't know if you Google that, if it'll come up or not. It's like not on Medium or anything.
I'll give a huge second to that too, Joe. That was one of the best articles I've read in a long time.
Yeah, didn't you like comment on that or something? I think I saw some traffic from you, which did not surprise me at all.
Yeah, I wrote a kind of a yes and article, but I really like that was, I love that post so much. I'm so glad you brought it up.
Now I realize I actually found that article because of I was reading your newsletter and you mentioned it. That's actually where I got to the article. But like, I was just astounded by the way that the person lays out the arguments and talks about it. And I was like, wow, I feel like my mind has been opened up to a reality that I wasn't paying attention to enough. And what's interesting is I had some conversations with Rob Wormold on the Angular core team about basically this very topic and how what's going on with like server-side rendering, and frameworks do the server-side rendering, and then they try to bait and the smoke and mirror show where behind the scenes, and they just tear everything out and put stuff back in, and that just isn't really sustainable. Again, so it's somewhat of an okay solution, but in a lot of cases, that's not a great solution for trying to fix this issue. So great reading, and yeah, thanks for seconding that, Chris. And finally, my other pick is going to be last night. I've been playing a bunch of Dungeons and Dragons with some of my friends, some developer friends that I know, and we keep inviting Chuck, and Chuck keeps deciding not to show up. Well, we decided that we're going to start recording our sessions because a couple of the people that we play with are just hilariously comical in what they do. And I also think it's interesting just to show, how a group of people play. So if you're interested in Dungeons and Dragons or you play some, it's nice to see how somebody else plays. So we're recording our episodes on YouTube. We're editing them down to relatively as short as possible to just keep the important stuff in, and we'll probably be producing some blog posts. I don't even have the name of the channel on YouTube yet. By the time this gets published, hopefully we'll have that set and have the first episode published. But we're going to be videoing and putting out our Dungeons and Dragons sessions. So look for that in the future. And those are my picks.
Nice.
Yeah. Oh, and as a side note, we're doing the very, very, very new campaign that Dungeons and Dragons just put out, the Dragon Heist. So if you're interested in checking that out as well for just the content and seeing how somebody else plays through it, that's also another reason to watch. But if you don't like me and you don't like Dungeons and Dragons, please do not watch. I don't want to see you.
Awesome. All right, AJ, what are your picks?
Oh, I've got a boatload for you today. The first 28 that I'm surprised that Joe didn't pick are the 28 sessions of Utah JS Conference 2018 that are now live on YouTube. The focus of the conference, well, let's see. The suggested theme of the conference was accessibility. So there are a number of talks that have to do with things like colors and how you shouldn't use ARIA tags except as a last resort, because if you're using them, it means that you're doing other things wrong. And interesting talks like that. And I'm a big fan of accessibility because I'm like 0.01% autistic. And as such, I have a really hard time parsing flat design. And I take things very literally. And so making things that look and feel the same as what they're doing, like function over form and form following function, is like huge for my user experience. And I've talked to other people that tell me the same thing, but it's just not big in our community. And I think some of that came to light in the conference. So I'm excited. I gave a talk too. I'll maybe like tell you more about that another time, but do some other quick picks. I now have, I work at Big Squid now in Salt Lake. And so I have an hour commute there and back. And I've been like just blurring through audiobooks. I think Start With Why is a must read or must listen for everyone. There's a TED Talk that's like the short 5 or 10 minute version. But you should listen to the whole book. It's, and the reason why is that it will change your perspective in how you deliver your messages so that you can more effectively reach people, engage your audience, and win people to your side by exposing to them what it is that you believe rather than what you're doing because of that belief or how you're accomplishing what you're doing. When you share your why with people, why you're doing what you do, you win people over to your side based on how they feel. And it's a stronger attachment. And I hope that's a good intro to the book. I'm also going to pick Chris Ferdinandi because I've also subscribed to his mailing list. And I think about 3 articles come in a week or so. And maybe that's more than that. Maybe it's less. But I open them every once in a while, and I enjoy his insights. So props to our very own co-host here.
How much do I owe you guys for these endorsements?
And nothing. You're doing a great job. Keep it up. That you owe me more quality posts to my email. And then, as some of you are kind of getting the hint, I'm kind of at odds with the JavaScript community at large. So I'm exploring other areas. I work as a full-time Go developer. I'm reading the Rust book. I hope to soon have a talk out of why you should not use Rust. But the catch is I think that maybe you should, but probably most of you listening shouldn't. But check it out. If you, when people tell you what it competes against, they're wrong. Rust competes against C and Python. That's what you need to know. That's the tip of that iceberg. And last thing is I also listened to 0 to 1, which at first I would say it didn't go on my must-read list. It's got a lot of information, but I think you can get more value out of hours spent listening to some of the other books I've recommended over the years. However, in context of this, the developer experience bait and switch, I think his perspective on indefinite optimism, the idea that we, especially in American culture, he talks about how this is a very American thing, tend to believe that things will get better without actually considering the effort that we have to plan to put in for them to get better, just because the way that we've grown up in our generation with how history is shaped with wars and politics, et cetera, we've kind of had things just get better without having to put in effort. And so we have this culture of indefinite optimism that may be our demise. And I think that was actually super evident in this developer experience bait and switch blog. Even though he doesn't use that terminology, it kind of describes that problem that we have. So huge list of picks, but I think they're really good ones. So it was worth the time. If you don't believe me, believe me.
Awesome. Chris, what are your picks?
I'm going to pick another excellent Chris in the universe. I know we had Chris Beekler on the show a few weeks ago. He runs this really awesome site called Close Brace that has a ton of free tutorials on JavaScript things. There's a lot of focus on Node, but there's also some really great vanilla JS stuff, particularly around some of the newer ES6 stuff and even what's coming after that. So if you want to focus on that sort of thing or learn more about it, and I strongly encourage you to, Chris's site is a fantastic resource that I use on a very regular basis. My second pick this week, and it actually dovetails nicely with what we talked about on the show. A few weeks ago, I decided I wanted to learn a little bit more about how frameworks like React and Vue work under the hood. So through a combination of digging through the source code and just trying to reason through it, I ended up creating my own little state-based component helper function called Reef that I put out on GitHub. It comes in at about 2 kilobytes minified and gzipped and really doesn't do a whole lot beyond just giving you a reactive state-based component, and I can see it really tying in nicely with microstates and all the stuff that we talked about today. But if you're craving a maybe closer to the metal experience, but also have the need for state-based components, that might be something you want to check out. And then my last pick this week is the world's premier artisanal sparkling water, LaCroix. I am a soda addict. My dad used to work for Pepsi when we were growing up, and we always had it around the house, and I've just always drank way too much of it. Now that my metabolism is slowing down, that habit is really starting to bite me. So I recently started drinking LaCroix despite having a lot of reservations because, I don't know, it seems like kind of an arrogant thing to do, but it has, for me, filled the void for drinking bubbly stuff. And I go through like 4 or 5 cans a day, but I don't drink soda all that much anymore. So big win there. All right, and that's my picks for the week.
Awesome. I'm looking forward to Chris inventing the not so vanilla JS framework. Or I mean Reef. Sorry.
Yeah. It's and if you ever want to, like, we can talk into whether or not that was a good idea at some point if you want. But it was just a really interesting exercise. I learned a ton. I actually used it on a project that was pretty cool. Anyways, I'll shut up now.
It's all good. I've got a couple of picks myself. So one thing that I've been working a lot on lately is the podcasts. I've done a couple of different things. So if I'm just going to throw some of it out there, I tend to dump my stuff like, hey, this is what I've been working on the My Story episodes and not on the JavaScript Jabber or Ruby Rogues episodes. But yeah, I've kind of been playing with a few things and I've really been diving in and enjoying it. So one of them is, if you're interested in podcasting, I have been working on a system that will manage podcasts. And it's interesting because I worked on it for 2 months and then realized I was kind of headed off in the wrong direction, even though I had built a lot of the parts that I need for the right direction. So we're a number of episodes ahead. This will come out sometime in November, I think. By then, I should have a beta up. So if you go to podwrench.com, you should be able to sign up for the beta and get started with your podcast. I'm also playing with some ideas around doing some sort of guided setup or even a concierge. We're going to launch and run your podcast for you kind of service. So if you're interested in all of that, that'll all be at podwrench.com. But yeah, it'll do everything from manage your RSS feeds to help you line up guests. And if you're running a show like this one, also manage hosts. I'm hoping to get to the point where if somebody, chimes in and says, hey, I can't make it this week, so if Joe comes down with the plague and he needs a day to recover, then, it'll reach out and it'll say, oh, well, we've got these other people who said they'd fill in and we'll see if we can get somebody to fill in. And that way we make sure we always have a full panel and then a good discussion like we did today. So I'm working on that. I also have the Get a Coder Job book that I'm working on. People are buying the book and the course on devchat.tv. Eventually, the book will go on to Amazon, but if you want to pre-order it, you can. And hopefully, that'll be mostly done by the time this goes live. The course will definitely be out the videos, so definitely check that out as well. And yeah, that's kind of what I've been working on. A few things that I've been playing with are Elixir and Phoenix, and that's been a lot of fun. We have an Elixir podcast at elixirmix.com. And then I've been using Vue.js on the front end. and that's also been awesome. And the project that I decided to build is just kind of a test app, is sort of a dashboard. So you can just put entries into it and it'll, make graphs for you. And I'm using Kendo UI on the front end. Kendo's a sponsor, and I wanted to play with it a little more deeply so that I could speak to it a little bit better on our sponsorship. So anyway, lots of picks around that stuff, but yeah, that's what I've been playing with. Taras, what are your picks?
I have two. So one pick is, Charles has been doing streaming of his coding on Microstates on Twitch. And I've learned more from pairing with Charles than I probably have from any other programming that I've ever done. So I would highly recommend just the way Charles solves problems. And you can see it in Microstates because it's the code is it's a very fascinating code base. It's very tiny, but it does a lot. And to get the kind of things that Charles has done with this latest iteration in Microstates, it's pretty incredible. So if you're interested in functional programming and in really like kind of opening up your mind to different ways of thinking about what you could do with functional programming, Charles's stream is really, really good. And my other pick is BigTest, which is the library that Charles mentioned earlier that Frontside has been maintaining or created and is growing. It's an acceptance testing framework, and there's really it was actually pretty cool because Rob from our team was presenting it at JSConf, and he was going right after Cypress, which is another kind of similar tool, but we found out after JSConf that for the same test suite, so we implemented big testing for to do MVC using the same tests that Cypress uses, and big test is 10 times faster than Cypress.
Oh,
so,
wow.
Yeah, it's pretty incredible. I mean, it's hard. Like, it sometimes helps to do those kind of comparisons to see the real difference. And this is huge because for big test suites, like it's not unusual for us for Frontside to have a project that has 1,000, 2,000 assertions. So that kind of test suite can with something that is 10 times slower it could easily take 10 minutes, 10, 15 minutes, and that's a really big difference. So big test, if you're writing front-end applications and you want to know that your application is working when you change it, like big test is a really good solution for that. And those are actually, I will add one more pick. If you're looking for an awesome team to work with, of very kind people who really know their programming, Frontside is the people. So we have some availability now. So if you're interested in working with us on Microstates or using big test, we would be more than happy to get you set up. And one of the things that's really special about how we work is that we make training our client's team part of our deliverable. So we actually embed ourselves into our clients' teams and mentor and plan mentoring of our clients' developers as part of the deliverable. So it's any team that works with us is going to learn a lot. So highly recommend it. That's it.
Great. Charles, what are your picks?
I was actually inspired by the chatter at the opening of the podcast, but I stand behind this pick. So I've got two, and they're both centered around the same thing. The first is chalkboards. My chalkboard is absolutely integral to Microstates development. I stop while I'm working constantly to be able to draw out a solution or just try and model or visualize a problem. And I think a chalkboard has a number of advantages over whiteboards. It's a little bit more expensive, but the feeling and the texture is just more visceral when you're writing on a chalkboard. You don't end up with I think it's more ecologically sound in the sense that when you use chalk, it's gone. It lasts longer. You can tell when you're almost out of chalk, or you can't really tell if you're almost out of ink. Although I think that most whiteboard dry erase markers end up getting thrown away prematurely. So there's, landfills are filled with plastic tubes. And then the second pick would be Sargent Art, colorful and colorless, dustless chalk, which means that you can write all day on the chalkboard, but you don't end up with big fingerprints on your pants and your shirt, and you're not sneezing all over the place, and there isn't a film of dust all over your desk. Those are my 2 picks.
I have to say, you talked about all the reasons why dry erase markers get thrown out early and things like that, and you didn't address my major problem with that, and that's my kids. So they come into my office and they draw on my whiteboard, and then they either disappear or get left open. So.
It's true.
I don't know if a chalkboard would solve that, though.
The chalkboard, they do break a lot of the chalk. But ultimately, chalk is less expensive. I think a thing of 12 or 20 pieces of chalk is about $3.99. So you pay less cost in there, and you can write with tiny little nubs of chalk. I actually hide my chalk. I brought it out so I could see the brand, but I actually keep it well hidden.
This is Dad's special chalk.
Yeah. Charles' other pick is a box with a lock on it.
Yeah.
All right. Well, one last thing then, I guess, is how do we find you guys online?
Well, you can find me. I'm Cowboy D pretty much everywhere. So I'm at Cowboy D on Twitter. I'm Cowboy D at Frontside.io. That's generally how you'd reach out for me. And I'm Cowboy D on GitHub, of course.
Where does that handle come from? I'm curious.
It actually comes from my freshman year in college, where I went to Michigan and I was the only person from Texas. And folks started calling me Cowboy Dan for some reason. And this was in the first few weeks before class. And so when I signed up for my email address, I was cowboyd@umich.edu. And I've kept that handle ever since. That was back when you actually had to go into the computer lab and register for an email address, and they printed it out on a dot matrix printer and handed it to you.
Nice that you get to pick yours. My university chose to include the last 4 of your social as part of the email address.
Oh, man. Yeah. Well, I think they'd had email. Yeah, it was not, it was longer ago than I care to admit.
Hey, your email address is your first initial last name and last 4 of your social. What could go wrong?
Hey, they could have gone with the whole thing.
I prefer to have my mother's maiden name in there as well. As my middle
number at the end.
Yeah. Halfway through my college career, they passed the law that said that they couldn't use your social as your student ID. And so, everybody got reissued student IDs. I was working in IT at the university at the time, and I can tell you that was a huge headache. Anyway, Taras, how do we find you online?
I don't know how this happened, but I'm Taras on GitHub, and I tried to get Taras on Twitter. It didn't work, so I'm Taras M on Twitter. That's probably the best way to find me on Twitter or GitHub.
Good deal. All right. Well, thank you both for coming. This was a fun conversation, and hopefully people are inspired to go check out these solutions, because I think the more that we see the way that these things can be solved, I think the better the community gets at large. And so, coming on and sharing these ideas is really important. I really appreciate it.
Thank you for having us.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CACHEFLY.com to learn more.